Good morning, children. Today we are going to study about the nomenclature of, in this video we are going to study about the nomenclature of aromatic compounds. So already we have studied what is meant by an aromatic compound, isn't it? There are different types, two main types of aromatic compounds like benzenoids and non-benzenoids. And for us actually we have only the aromatic compounds as benzenoids, that means compounds containing benzene ring. So whenever you get an organic compound containing benzene ring, we can say that it is aromatic because benzene ring is always aromatic in nature. So for us in class 11 and class 12, we have only the aromatic compounds. For us, aromatic means it is the compounds containing benzene ring. That is easy to remember. So all the compounds containing benzene ring is aromatic. So how we can do the naming or the nomenclature of compounds, organic compounds containing benzene ring? So already in the previous videos, we learned how to do the naming, IUPAC naming of ring compounds, that is alicyclic compounds, not aromatic, alicyclic compounds. That means other than benzene ring, if there is a ring compound or if we are getting a ring compound, how we can do the naming and how to do the numbering. So everywhere, whether it is an aliphatic compound or aromatic compound, the basic rules are same. So when we do whenever first we have to identify the parent or the word root, then after identifying the parent chain or parent ring, whatever it is, we have to do the numbering. And when we do the numbering in an aliphatic chain or in a chain compound, that is different from when we do the naming or numbering of a ring system. In ring system, we can do numbering either in the clockwise direction or anti-clockwise. But if it is a chain compound, we have to do numbering from left to right or from right to left or from top to bottom or from bottom to top. So then here also we have to apply the lowest sum rule, the substituents or the functional group, they should get the lowest possible number. So if there is more than one functional groups present, the principal functional group should get the lowest possible. Okay, etc, etc. All these are applicable here also. But what are the additional things that we have to remember when we do the naming of an aromatic compound or compound containing benzene ring? Now, before we go to the IUPAC naming, okay, we have to study there are certain names. These are actually common names, certain common names which is accepted by IUPAC. So, when they ask the IUPAC name, if you write these common names also, that will be correct because these common names are actually accepted by IUPAC. So very frequently used few compounds with their common names we are going to study now. The first one we know it is actually the simple benzene ring, isn't it? Which ring is this? A 6-membered ring containing alternate double bond. Which ring is that? Actually benzene ring. So what is the name of this compound? It is benzene. So benzene is actually an IUPAC name as well as a common name. So it is an IUPAC accepted common name. Now chlorine attached to next compound. In the next compound, chlorine is attached to a benzene ring. So how we can do the naming? So here the parent we can consider the only ring or the only there is no chain at all. The only ring present is benzene ring. So this compound we can consider it as a derivative of benzene. So here the name is chlorobenzene. Chlorine attached to benzene ring. What is the name? It is actually a IUPAC name, or we can say it as a common name also. It is chlorobenzene, a very common compound that we are using or we are studying. Now OH group, when it is attached to a benzene ring, if an OH group, if it is present in an aliphatic compound or a chain compound, we will call them as all those compounds containing OH group attached to a chain, we will be calling by the name that is alcohols. But when OH group, when it is attached to a benzene ring, it will become an aromatic alcohol, and the aromatic alcohol name is phenol. Okay, so when OH group is attached to benzene ring, the common name of the compound is phenol. Now CH3 group attached to benzene ring, the common name of the compound is toluene. You might have heard about TNT, that is trinitrotoluene, an explosive. So that is actually a derivative of toluene. So what is toluene actually? It is benzene ring containing a methyl group as a substituent. Now the next is NH2 group attached to benzene ring. So the common name for this compound is aniline. NH2 group attached to benzene ring. The common name of the compound is aniline. You must study the common names of all these compounds and their structures. Now the next one is CHO group attached to benzene ring. Here the compound name is benzaldehyde. CHO group attached to benzene ring, common name is benzaldehyde. Now the next is COH group, that is carboxylic acid group attached to benzene ring. The compound name is benzoic acid. It is not benzenoic acid and all. What is the name? It is benzoic acid. Now the next very common compound that we have to study in 12th standard also, that is benzene ring containing COCH3 group. Okay, that means the CO group, we know that it is a keto group. One side of the keto group will be methyl group and the other side will be a benzene ring, and the common name of this compound is acetophenone, a very important compound. Okay, the name is acetophenone, and this can also be written as acetophenone. Here the benzene ring, it is attached to one side of the keto group is benzene ring. So the ring can also be written as, if it is simply a benzene ring, the formula will be, we know that it is C6H6. But if anything is attached to a benzene ring, so here at this position there is one COCH3 group. So anything we can attach to a benzene ring only by removing hydrogen from that position. So we know that in the structure of benzene, in all these 6 positions there is carbon atoms. So there is 6 carbon atoms, and on each carbon atom there is one hydrogen atom. That is why the formula is C6H6. But when we attach any group to any position, that is only by removing hydrogen from that position, otherwise we cannot attach. That means at this carbon there is no more hydrogen present. Okay, so here only one carbon is present, to that carbon COCH3 group is attached. So remaining, so total there will be 6 carbon atoms, and except at this position, in all the remaining other 5 positions there will be hydrogen. So formula will become C6H6 will become C6H5. So benzene ring as a branch means the formula will be C6H5, then COCH3. So acetophenone, the molecular formula is C6H5COCH3, a very important compound. Now the next is the next is again one keto group, and on one side it is benzene ring, the other side is, it is written as C6H5, and we know that C6H5 means what actually? Again it is a benzene ring, or this can also be written as CO with 2 benzene ring on either side. Okay, so acetophenone, benzophenone, what is the structural difference? In acetophenone, one side will be benzene ring, then the other side will be CH3. But in benzophenone, the compound name is benzophenone. On either side of keto group, it will be benzene ring. So remember, what is the name of, a common name of this compound? It is benzophenone. Or this can be also written as, if it is a simple benzene ring, it is C6H6. But when one branch comes, one hydrogen is removed. When two branches come, two hydrogen will be removed. So here in this benzene ring only one branch, so we can write it as C6H5. Then we have CO, then another benzene ring with one more branch, isn't it? So that also will be having the formula C6H5. So benzophenone, the formula will be C6H5CO, C6H5. So these are the very common compounds with their common names. So study all these structures along with their common names. Now we have to see, already we have studied about, in the previous videos already we learnt about alkyl groups. How is the general representation of an alkyl group? It is represented by capital R group with a free valency. Isn't it? Since they are all the groups, we have to write with a free valency. So like alkyl group like methyl, ethyl, isopropyl, secondary butyl, tertiary butyl groups, etc. We have aromatic groups also, and they are called by the name aryl groups. So which are the aryl groups we have? The first one is already we learned, already just now we studied, that is C6H5 group. It is actually the free valency. Why it is actually a free valency? Because it is a group, isn't it? So C6H5 group is known as phenyl group. Okay, C6H5 group is known as phenyl group. How we can draw the structure of phenyl group? Yes, benzene ring. If it is attached to something, that means don't remember that, don't misunderstand the structure. Don't think that here this is a bond line representation and here there is a carbon. No, nothing. This is actually a benzene ring coming as a branch. Okay, so that dash is actually representing the free valency only. So when benzene ring comes as a branch, it will be, when it comes as a parent only, we can call it as benzene. When it comes as a branch or substituent, what is the name? It is phenyl group, and the formula is C6H5. Okay. Now the another aryl group is, or branch is C6H5CH2 group, that is benzyl group. And how we can write the structure of this benzyl group? We know that C6H5 means benzene ring coming as a branch. It will be attached to something, some other carbon or something else. And which is the group present here? CH2. And the free valency is on this carbon, CH2 carbon. So if it is a benzene ring coming as a branch, it will be called as phenyl group, and if it is benzene ring containing CH2 group, it will be called as benzyl group. Okay, then you can understand very easily. For example, if chlorine is attached to a benzene ring, it will be called as chlorobenzene, isn't it? But when the same chlorine, if it is attached to a C6H5CH2 group, that is benzyl group, it will be called as benzyl chloride. Difference clear? This is chlorobenzene and this is benzyl chloride. So these are the some basic or some very common compounds that we must study before we start the UPSC naming. Now we know that when we do the naming of a ring system in IUPSC, we are using only numbers, isn't it? We cannot use we cannot use alpha, beta, gamma, normal, isoneo. So in IUPSC system, we are using only numbers. So aromatic compounds means we know that these are the compounds containing benzene ring. So how we can do the naming of, or how we can do the numbering of a benzene ring? So this is a benzene ring. If it is a simple ring, from all the 6 carbon atoms are in equivalent position. So from wherever you want, you can start numbering. Okay, so if I am starting from here, So wherever you want, you can start numbering. The only thing is you have to apply the lowest sum rule. The highest priority functional group should get the lowest possible number. That all you have to keep it in your mind. So here it is a simple benzene ring. So from whichever carbon you want, you can start numbering. But the only thing is we have to move either in the clockwise direction or in the anti-clockwise direction. Any one direction only we can move. So I am numbering as 1, 2, 3, 4, 5, 6. Okay. Now if you want, you can number like 1, 2, 3, 4, 5, 6 also clockwise or anti-clockwise. Or if you want, you can start from this carbon 1, 2, 3, 4. Or if you want, you can start numbering from the other carbon. Okay. Now, so when we do the numbering, there are certain terms that we use in common systems. For example, if two functional groups or two substituents, if they are present at 1 and 2 position, 1 and 2 position means what? They are adjacent positions, isn't it? So 1 and 2 are adjacent position, 2 and 3 are adjacent positions. For example, if two chlorine atoms are coming at 1 and 2 position, they will be called as ortho. Okay. So 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6, and 1 and 6, all these are adjacent positions. So in IUPAC we will be using numbers like 1, 2, 3, 4, and these adjacent positions are called by the name ortho positions in common system. So ortho is a term that we use only in common system. So ortho means what? Adjacent positions are called by the name ortho position. Similarly, positions 1 and 3. 1 and 3 are actually alternate position. 1 and 3, 2 and 4, 3 and 5, 4 and 6, 1 and 5, 2 and 6, all these are alternate positions. Okay, so in IUPAC it is 1, 2, 3, 4 like numbering, but the alternate positions are called by the name meta positions in common system. So if you see meta, that is alternate positions. So the substituents will be present at alternate positions. If it is ortho, adjacent positions. Now, positions 1 and 4, 2 and 5, 3 and 6. Okay, then so these are called by the name, they are called as opposite position. 1 and 4 are opposite positions, 3 and 6 are opposite positions, 2 and 5 are opposite positions, and these opposite positions are called as para position, and the para is also a term that we use in common system. Now, the short form of ortho position is small o hyphen ortho, meta, para. We never start with capital letters, use only small letters. And the abbreviation of ortho position is small o hyphen. Meta position, the abbreviation is small am hyphen. And the para position, the abbreviation is small p hyphen. So, don't ever use capital letters to represent ortho, meta, para. And remember, these are the terms that we use only in common systems. So this is about regarding the numbering of an aromatic ring or benzene ring. Now we will see what are the additional rules or what are the additional points that we have to remember when we do the naming of an aromatic ring or compounds containing benzene ring. So for example, first one, if an aromatic compound contains, if it contains more than one functional group, okay, if it contains more than one functional group, the compound will be named as the compound, as a derivative of the compound with principal functional group, okay. For example, we will see here in the benzene ring we have one COH group and NO2 group. So here also we have to study the priority order. And we know that when you compare this priority of COH and NO2, COH is having highest priority, and NO2 is a functional group which is always considered as a substituent. It is not at all coming in the priority order. So how should we number it here actually? So we have to start the numbering from which one should get the lowest possible number? 1, 2, 3, 4, 5, 6. So this compound, how should we name it as a derivative of the principal compound with principal functional group. So here benzene ring containing COH, we have to take it as the parent. So this is actually a derivative of benzoic acid. So how we can name this compound as? So the parent is benzoic acid. So this we can consider only as a derivative of benzoic acid. And which derivative is actually in benzene ring? Sorry, in benzoic acid at the 4th position there is a nitro group. So how we can name it as? It is 4-nitrobenzoic acid. So N should be capital. Now the next rule is, if all the functional groups present in the benzene ring, they are substituents only. Substituents means they are functional groups but with least priority. Okay, so if such groups are present, they are numbered in such a way that the one comes first according to the alphabetical order should get the lowest possible number. For example, here we have a benzene ring containing bromine and chlorine. We know that halogens like nitro group halogens are also not included in the priority order. They are considered only as substituents with least priority. So we can number either, the first possibility of numbering is when we number the substituent should get the lowest possible number, isn't it? So either we can start from here 1, 2, 3, 4, 5, 6. So the substituents will be present at 1 and 3rd position, 1 and 3. Now the next possibility is we can start from chlorine 1, 2, 3, 4, 5, 6. So whether we do in the clockwise direction or anti-clockwise direction, bromine and chlorine, they are getting the positions 1 and 3. But which one should we select? If we do in the clockwise direction, bromine is getting position number 1, chlorine is getting position number 3. But anti-clockwise direction if you do, chlorine is getting number 1 and bromine will be getting number 3. So which one should we select? Both are substituents with least priority. So no need to see the priority order. The one which comes first according to the alphabetical order should get the lowest possible number. So which one should get the lowest possible here? Bromine. B is coming first. So which naming should we select? Yes, this one. The one which is written with yellow color. So how we can name it as? Here it is 1st and 3rd carbon there is bromine and chlorine. So here the parent is benzene. Okay, because bromine and chlorine they are always used as prefixes. So it is 1 bromo, 3 chlorobenzene. There is one more compound given, benzene ring containing chlorine and 2 nitro groups. So here also the one which comes, because all the 3 are considered as substituents only. So 1, 2, 3, 4, 5, 6. So here also they all will come as prefixes only. So the parent is here also it is benzene. There is no principal functional groups present. So how should we name it as? It is 1 chloro, then at 2nd and 4th position, so 2,4-dinitrobenzene. Now the next rule is when benzene ring is attached to an aliphatic chain, when benzene ring is attached to a chain and the chain is containing functional group, not the benzene ring. The ring is attached to an aliphatic chain and the chain is containing the functional group. then which one should be selected as the parent? Only the chain. Okay. So the compound will be named as a phenyl derivative. Why it is considered as a phenyl derivative? Why phenyl? Because benzene ring will be considered as a substituent only. So when benzene ring is considered as a parent, it will be called as benzene. But when it comes as a substituent or branch, it will be called by the name phenyl group. So here, when ring is attached to a chain and the chain is containing functional group, the compound will be named as only as a phenyl derivative. See the example here. Here we have a benzene ring attached to a chain system and the functional groups are present in the chain. So which one should be selected as the parent or the word root? We have to select from the chain only, isn't it? So this is the parent. Now it is an aliphatic compound. So first we have to do the numbering in the chain. How should we do the numbering? So here remember, so which are the functional groups or substituents present in this ring? There is a CHO group functional group, there is an OH group functional group, and there is a phenyl group. Now this benzene is not a parent, it is a phenyl group only as a branch. Now from where should we start numbering? Yes, we have a terminal functional group, that is CHO with highest priority. So this carbon should be always numbered as 1, 2, 3, 4. So what will be the name of this compound? How we can write? Chain compounds, how we are doing naming? 4 carbon means the word root will be but. All these 4 carbon atoms in the parent chain, it is singly bonded, so it is ANE. Now we have 2 functional groups, CHO and OH. The principal functional group is CHO, so that will go as secondary suffix. So replace E and write it is 1-al. Now, so OH will go as prefix, and we have one phenyl group also, that will also go as prefix because that is only a substituent. So OH prefix is hydroxy. So hydroxy and phenyl, which will come first? Yes, hydroxy. So the name is 3-hydroxy. Now 4-phenyl butan 1-al or butanal. So here benzene ring, this compound became a phenyl derivative, or benzene ring became what? As a branch or substituent. So these are the few rules that you have to remember when we do the naming of IUPAC naming of aromatic compounds, and study all the common names before you do the IUPAC naming. Okay.